Okay, good morning. Video for 6D part 2 should be pretty short. I just want to go over extraneous solutions one more time because there's something that I kind of missed yesterday that I'd like to go over. Sometimes what we might see on a test is they may ask us to find the extraneous solutions of one of these square root functions here, particularly when you have a root on one side and a regular x on the other side, is most of the time when we're going to see it. So even though, when we're solving the equation, we want to eliminate extraneous solutions, sometimes they may want us to find out exactly what those extraneous solutions are before eliminating them. And I want to sort of show you guys how to do this without having to do the math with it. Okay. So in case you ever have to do an extraneous solutions, here's how we can sort of do that. All right. Is number one is we'll take the equation, we'll square both sides and do the graphs of each side, and we'll probably get two solutions. So I'm going to take number 34 here real quick. Okay. So we have x minus 6 is equal to the square root of 3x. So if we were to square both sides and do the graphs, one graph would be y equals x minus 6 squared, and the other graph would be y equals 3x, because we're just taking this thing and we're squaring both sides. So if we go and do this real quick, so we have, y equals x minus 6 squared, and then y equals 3x. So we have our graph right here, and our two solutions are going to be, looks like 3 and 12. All right, so 3 and 12 are going to be our two actual solutions. Okay, so we'll get our two solutions. So in this one, we get 3 and 12. All right. Now, in order to get all the real solutions, we'll do step 2, which is graph the equations as they are. Okay, so we'll do x minus 6 and then root 3x. All right, so what we'll do is let's do x minus 6, and then we'll do the square root 3x right there. All right, so we graph that up, and here we get 12 is our one solution, and that's it. 12 is our one solution. So we come back here, and when we do it properly, all we get is 12, meaning that the 3 was extraneous. Let me reiterate that, doing this just to solve for the actual solution is fine. Okay. The reason that we're doing this part here, this first part, is to find out, okay, are there any extraneous solutions, and what are they? Okay, so in case the question asks for what are the extraneous solutions, which we may see on our test, or you may even see it in the future. And so this is a way we can do it to where we can get all the solutions without having to do the actual math and algebra. Okay, so to do that is you just square both sides to get rid of all the radicals, and then you kind of just graph them and sort of go from there. Okay, so you square both sides, graph them, you get your two solutions, and then you go back to step 2, doing what we did yesterday, which is just graph them as they are, and then you'll get your answer. That's the first part of 6D part 2, so you can go try these problems out down here. Coming down to the second page, just wanted to recap from Unit 4. So whenever we have a rational, okay, when we raise to a rational exponent, a rational exponent is a funky word for fraction. So whenever we hear about a rational number, or rational this, or rational that, it just means fraction. All right. What happens is the numerator is going to be the power, and the denominator is going to be the root. Again, best way to solve these is graphing with, calculator setting one side equal to y, setting the other side equal to y, and figuring it out. If we do it by hand, we got to solve for the variable. So first thing we're going to do is we're going to get the variable by itself. All right. And we're going to raise both sides to the reciprocal exponent. Okay. So get the variable by itself, raise both sides to the reciprocal exponent. So if we're coming down here looking at number 23, so we have 2x to the 2/3 power equals 32. Again, if we want to just go and graph it, we can go ahead and graph it. But if we wanted to solve for x manually, so first step is we'll get the variable by itself, so divide by 2, divide by 2. And so we have x to the 2/3 power equals 32 divided by 2, which is 16. If we wanted to convert this into a root, we could. X to the 2/3 power, if we remember, is x squared to the third root, which you could write that if you want to. In my opinion, I think it's quicker to get rid of this exponent by raising to the reciprocal exponent. So if the exponent here is 2/3, if we raise this to the 3/2 power, that'll cancel the exponents out. We just got to make sure that we do it the same thing with the 16. Okay, so what we end up with is x is equal to 16 to the 3/2 power. And that we could just type into the calculator right there. So we'll just go 16, raise it, and then I'll put parentheses right there, 3/2 power, and we get 64. Kind of ties into roots because remember, a fraction rational exponent is just a power there and a root there. But it's another way we can kind of solve these root things if we so choose. And so 16 to the 3/2 power is 64. And just a note, there should not be any extraneous solutions if the denominator is an odd number. Okay, so here we have 2x to the 2/3 power equals 32, and x is going to be 64, and there's not going to be, any issues there. Okay, if we have 1/2 x to the 5/2 power equals 16, there's a possibility that we may have an extraneous solution, particularly if we have an x on the other side. But I don't really think that's going to be the case there, but you could always go back to what we did on the first page to check. Okay, so that's our 6D part 2 notes. If you have any questions, please let me know, and you guys have a good day.